All right. Now, board's going to be a little weird because I don't know what's going on. It seems like the screen is still not the same from before, but we'll do the best we can. As you know, these are the notes. We should be able to complete these notes with some time to spare. You also have a second piece of paper. Okay, let's have eyes and ears either here or in there. You also have a second piece of paper, homework assignment. That's due at a moment. I'm going to have it due on a 16. Let me see, hopefully my days are right. Morning. Okay, we do meet on the 16th, so it's not going to be next class, but the following class. You should write this down. Write this in your, write this on your paper. Write that on your paper, that homework piece of paper. Write down that due date. If you haven't done so, do it now.
Your homework?
Yeah, that one little piece of paper. Yep, that's our due date. We may start the unit 5, day 4, 5 notes. We may start them today. Don't know. If we do, that's okay. But we definitely should be able to get through these guys, these first two. Day 3 notes on similar triangles. Homework you should be able to start. Might have put it up, I don't know yet. And then, yeah, all right, that's definitely it. And if there's time, we'll talk about day 4, 5. Monday, we're going to continue the day 4, 5 notes. If we don't start today, we're definitely going to get through them. Wednesday, we're going to do a test review. And Friday, a week from tomorrow, take super note. It's going to be a Unit 5 test. All right? So, somewhere, some way, somehow, this is your number 1 reminder. Unit 5 test next Friday. Okay? Put it. If it's agenda, if it's phone reminder, whatever you need to do to remind yourself. Test on Friday, the 18th of February. Okay? Any questions before we start? Okay, you're good. Yep, no, I was aware of this, so you're okay. All right, so you have a piece of paper, that's homework. We'll be quick. We'll probably go over it for a little bit. Notes, they should not take the whole period. And they're gonna be graded notes, so complete it, look at it, you did it, you're going to get credit for these notes, all right? Okay, we're going to begin at this time. All right, so let's get started. Again, some of my notes might be a little wonky. I mean, it's probably positioning more than anything. Let's figure this out real quick. Yeah, I know. I don't know why my screen's acting funny. Been like this all day. All right, basically, I think we're going to go back and forth on this. So, what's going to happen? As we start today, we're going to prove triangles are similar. Not necessarily congruent, but only similar. There's going to be 3 ways we can figure out when 2 triangles are similar. The first way we prove 2 triangles are similar, 2 angles from one triangle are congruent with 2 angles from the other triangle. So that's with your notes for today. This is the first slide. Okay. That's going to be the first slide you see. And then, basically, this is the one you have to worry about. Angle postulate. Two angles from one triangle, angle A, B are congruent to angle D and E. Then these two triangles, ABC, will be similar to DEF. So basically, we pick two numbers, such as, I don't know, 37. Yeah, I don't know why and I don't know, 72. 37, 72. I think that's 109, and then this last one right here. They both have to add up to 180. So the first two triangles from one triangle are congruent from first two angles of the second triangle. The two triangles will still be similar because the third angle has to match up.
So we're seeing FDX, and we have to find
If need be. But for similarity, you don't even have to do that, Des. So I'm just throwing that case example. So once you see that two angles from one triangle are congruent to two angles from the second one, that's all you need to say that they're similar. So not necessarily.
oh, so if it's 180.
Yeah, because they have to, because this last one, I think it's 71. Even if you didn't know that, even if you did not know, even if you didn't know that, as long as the first two were from one triangle are congruent to the second, then that's all you need to prove similarity. Not necessarily congruent. You don't need, so similarity, the rules are actually a little easier, for at least for the angle. But as long as you have two angles from one, congruent to two angles from the other, then yeah, you can say that they're going to be similar. All right, questions on this first idea? Because I know on your homework, there's going to be a couple problems where, and they're just going to give you the rings, the number of arcs, because that's all you need to show whether or not two angles are congruent because of the arcs, right? So once you see that, you're good to go. Now, some we're going to have to work for. It's, I think, not so much the first one that we do. Actually, I'm wrong. This was, let's see. Okay, yeah, we're going to have to work for these a little bit. But that's not bad. Because here, what's going to happen, now the idea of finding that third angle is going to be important. Now I know where you're going, Des. Good point. So if we go to the next page, now I know the notes are going to be a little wonky. Because apparently, I don't know why my screen is just way too big. But you know what? We might be okay. All right. If we look at our two triangles, now, what do we know for all triangles? The sum of all three angles of a triangle must add up to how many degrees? 180. You know that angle J plus angle K plus angle L is 180. Well, we have at least two of them. J is 45. L is 85. So you need to figure out what number, what's that other number, such that we get 180. I want you all to figure out what angle K should be. And then let us know. You need to do that first. You know all three angles have to add up to 180. But now we need to figure out, let's find out what angle K is first. Once somebody gets that angle measured, raise your hand, let us know. What's up? Yeah, 45 and 85. What do we get? 130. Angle K is going to be, you're going to have to add 130 to angle K to get 180. So that angle K must have to be. Come on. So 180. So what's 180 minus 130? For angle K.
50.
Okay, so you get 50 for angle K. Now that first blank for angle K is 50. Now, similarly for angle Y, know that XYZ has to add up to 180. Angle X, angle Y, angle Z, adds up to 180. X is 85, Z is 50. So 85 plus something plus 50 adds up to 180. So what would angle Y be? I'd like to take a guess to what angle Y might be.
45.
Catherine says 45. Agree or disagree?
45.
For angle Y. Andy, you're agreeing?
Yeah.
All right, so 45 it is. Now, so 45 is angle Y. Now, actually, did we even have to find angle Y once we found angle K?
No.
We didn't, because we already had 85, 50, and then 50, 85. So technically you had it already. So you could have either done, or if you found angle Y first, you still would have been A-OK, because then you would have had 45, 45. You would have been solid. So as long as you have two angles from one triangle congruent to two angles from the other triangle, you're set. You're good to go. So that's why for this one, they're going to be similar because of the angle postulate. So in that last box, you're going to put double A for the angle postulate. Because two angles from one triangle are going to match with two angles from the other triangle. So far, any questions? And sometimes they're going to mark it with rings, like a single ring, double ring. As I think on one of your homeworks. That's how they're going to indicate some of these angles. Whether like a single ring, double ring, or triple ring. All right. Questions before we go to the next slide? All right. Next slide is going to be similar to this slide. So now they didn't give you any letters. They just gave you numbers. So for the first triangle, they gave you a 28 and a 37. So we don't know what this one is yet. But also here, in the in the larger triangle, they gave you the other missing angle. Now, they told us one angle was common. That was at 28 degrees. So now we have an option. We can either find the missing angle of the smaller triangle, or we can find the missing angle of the larger triangle. We could do either one. 115 for which one? The smaller angle is going to be 115. Very good. Because again, what must the sum of the three angles add up to be? Has to add up to 180. Zoe, you agree with Des? Zoe, you agree with Destiny? Sum of three angles of a triangle is 180 degrees. You agree to that? Yes or no? Even if you just nod your head. All right. Thank you, Valerie. So the smaller, 115. Or larger is how many degrees? The missing angle of the larger triangle is very good. So I like that. More of us are participating. And again, there you go. So again, you have it. You could either do the 28 115, 28 37, or the 37 115. And then again, there you go. There's your angle partial. So I apologize for anybody who just arrived. Screen's still acting a little weird. But we're going to make the best of it. We're going to have a great lesson today. All right. Questions before we continue? Okay. All right. So sometimes you're going to have to find a missing angle. Sometimes, on the next slide, okay, this is not the best. In fact, what I'm going to do, I'm going to make that diagram a little bit, I'm going to rewrite that diagram over here. Yeah, that bow tie looking figure. Boom, boom, boom. W, R. I said R was 45 degrees. Value of S, we don't know. V. I'm just rewriting the diagram above. B. So V and B, R and V, I should say, are 45 degrees each. Do we agree with this first statement? Yeah. We understand where we're getting 45 degrees each for R and V. Now, here's where the highlighter comes into play. So here, RSW is this angle right here. VSB is that angle right there. But what do we know about those two angles? What type of angles do we have? Whenever we have an intersection, what do we know about the two highlighted angles here? They're what type of angles? Begins with a V. Second? Say it louder. I want everybody to hear what you just said, Des. Vertical angles. We remember those, ladies and gentlemen, from back in the day? Vertical angles. That's what we have here. You know what that means when we have vertical angles? Actually, let me blue. Vertical angles. Therefore, What can we say about these two angles? They are congruent, yeah. So since we have a 45 here, well, we don't know what these guys are. We don't know that yet, but we do know that they're vertical, right? So that means these two are automatically congruent. So we have at least two angles from one triangle congruent to two angles from another triangle. Do we see that, ladies and gentlemen? Because here's the 45, there's your 45. There's your vertical. That's actually enough to say we have similar triangles because two angles from one are congruent with two angles of the other. So boom, there you go. That's all you need. Again, that's how you get the air posture. If you get the vertical angles, that tells you right there, you have at least one set of congruent angles. And then since the second angle, you have 45, we don't need to worry about that last angle. Everybody else works. You see where we're going with this? If you're not sure, talk. Tell me. Talk to me. Dime, por favor. So sometimes I'll throw the English and Spanish and then, spice it up a little. Sabor. You know what I mean? That's sabor. ¿Sí o no?
Where'd you learn how to speak?
Family, friends, and school. So it's a combination of the three. All right, questions? Now, the last one is a non-example. Here's why the next one is a non-example. All right. We look at our three angles. Well, obviously, we need to find out what angle C is. We need to find out what angle D is. But can we do that, ladies and gentlemen? We can. So, the question is, what number is here? What number is there? So that's our question. So we need to figure out measurements. Angle C, angle D. Once we get those, because yeah, you have one angle that's 92 degrees. We only have one angle that matches at the moment. But we need to find out whether or not, if there's a 57 going here, or a 41 going there. We need to figure that out. So, when somebody gets a measurement of angle C or angle D, let us know.
D is
47. Uh-oh. Do we see a 47 over here? Nope. What about angle C? Anybody get angle C? How much? 31. Do we have at least two angles matching? We have two angle measures from one triangle match up with two from the other? Yeah or no? No, we don't. Yeah, the 92 matches. But 57 don't match with 47 last time I checked. What would you rather have, 57 or $47? Oh. And 31 and 41. These don't match because let's say I have 41,000. Well, no. I should say if you had 41,000 and I traded you for 31,000, would that be a fair trade? No. I know if I said, I know what you would all said if I had traded 31,000, if I gave you 41,000, but if you gave me 31,000, I know you would all say that's a definite fair trade, right? So, yeah, so we only have one number that matches. That's why these two are not going to be, they're not similar. You only have one match. So that's the purpose of this last one. Okay, any questions? So the first one was rather easy. Two angles from one triangle match with two angles from the other. That's all you need for a similarity statement. Now, the next set of problems we're going to do is kind of going, it's now going to be a little more like the triangles, congruency. But the difference now is going to be the following. You could have one congruent triangle. But now for the side angle side similarity theorem, unlike the congruent theorem, these sides have to be proportional to each other. So the proportions need to work. So basically it's saying, if you go from bigger to smaller, you got to divide by the same number. Or multiply by the same number, depending on. And if you went vice versa, then you'd have to multiply by the same number. We'll talk about that more momentarily. And in the end, it could be a proportion as well.
So same thing that we've been
Yeah.
doing.
So basically, the same thing we've been doing. Yeah. So actually, don't worry about this part as much. Just basically proportion. The proportion is going to be the best way to figure this one. So remember, the angle between the two sides for both triangles have to be congruent. That's why you see the single ring here, single ring there. And I think on the homework, I think we have a problem that's just like that. I think number 2 on the homework. There's time, we'll go over it. We'll talk about some of the homework problems. But the most important part is you need to make sure, again, it goes back to the similarity statement. You're going to check whether or not two triangles are similar. Look at your similarity statement because that's going to tell you who pairs with who. AB, if we wrote ABC over DEF, that's going to tell you who pairs which side. AB is going to pair with DE. Or AC is going to pair with DF. So that's going to help us. So this similarity statement is going to be huge. Similarity statement tells us which angles and sides pair with each other. Just like the congruency statement from back in the day. You all remember that? Just put one set of letters over the other. Then you know who matches with who from the first to the second diagram. Because that's the key. We have to figure out who matches with who. If we get that match, then you're set. And then it's just a matter of substituting and solving that proportion. Any questions before we start these problems? Again, I can't stress it enough. Right there. Can't stress it enough. That similarity or the congruent statement, that is one of the most powerful statements that we have. Okay, questions before we begin? Again, I apologize, the screen's a little chopped. I'll just show you real quick. The two sides, these two sides are between the angle. So I'll write that down. Sides form. Okay, sides form angle. So you have to pick the two sides that form your angle, the congruent angle. Because angle D was formed from DE, DF. That's where we get them two sides. And similarly, angle A was formed from AB and AC. Okay, questions before we go on? And actually, another way you can do this, here's another way you can set up your proportion. This might even be easier for some of us. You could also set up your proportion, whatever works easier for you. Because you could also flip it. Like, because the original proportion we had, I'm going to write this proportion vertically up like this. ACDF. I want everybody to see that this is the same as this. What you can do, you want to make your lives easier, you can also write your proportion as the following. You can also flip these two. You could have AB over AC, DE over DF. Reason why I'm going to say that is the following. I know it's going to be a little tough, but you'll see it easier with DE, because notice how DE that is like above the angle, and DF is below the angle. Do we see where we're going with this? That's why we put DE above DF. Similarly, you could also have your proportion set up where AB is above AC. This is another way you can set up your proportions. Because in the end, you're going to get the same result. So, because for some of us, it might be visually, and you're going to see it on the first problem. And that might be a visual advantage. Because we see right away, okay, check the ratio between these two. And those two, it's the same. You're good. You're good to go. So that's another way you could do these types of problems. And I'm going to show you right away on the first problem. All right, are we ready to go? All right, let's do this. Okay, now, all right, okay, here's one way you could have done it. What we did was, I'll fill in these blanks for you. Okay, in fact, all right, I got an idea. Here's how we're going to make this easy. We had one way you could have done it is I'm going to try to make this as easy as possible for everybody. What we did in one case, you could do it because they match the short sides. You know how, does everybody see in the first triangle, the 5 and the 10, they correspond to each other? Does everybody see how the 5, the WX, so WXU? And then U, V, T. Notice how, everybody see how WX, you know that's the short leg going up for the smaller triangle, and the short leg for the bigger triangle? We see that they correspond to each other, right? Because you could also do it like this. You could bring it up as you can write it as two smaller triangles. But notice how the right angle's in the same spot. The shorter leg is going up in both cases. The longer leg shooting out to the left. So that's one way you could have set up your proportion. So that's how we're going to match the WX, which is this top triangle, and UV. That's how those two are going to match. That's step number one. Now, we also know that UX or XU, which actually I'm going to write it, matches with VT, the larger triangle. We agree. WX, UV matchup, XU, VT matchup. Do we agree with that? All right. Now, in both cases, if we simplify 5 over 10, or 14 over 28, do we get the same decimal or fraction? What do we get?
140.
Oh, I see what you do. You did the proportion. Yeah. You can do it that way too. Yeah. You're right. I'll give you that. You showed me another way. Boom. 10 times 14,
25.
28 times 5, 140. You can do it that way too. You didn't do anything wrong. That's another way you can show it. They're proportional. You simplify the fraction in both cases, bang, you get 0.5. That works too. So again, what you did was not wrong. In fact, I like this method too. Because we may not always get that simplified decimal or fraction right off the bat. So the other way, do your cross multiplication. Do that diagonal. If they match, bang, you're good. Now, the other way, we could have also figured out, all right, angle X and angle B. Why are those two angles congruent to each other? Dang, they're about 90 degrees. So, that's going to be the SAS because you have two sides. This side corresponds to that side. There's side number one right there. That's side number one. Your right angle, there's your angle. Boom. There's your angle. And then you have your other side. Boom. There you go. That's your side angle side right there. Yeah, go ahead. Yeah, that's fine. You're good. Now, the other way you could set this up, this might be easier for some of us. What if we did, here's another way you could have done it. What if we did, if we look at that triangle right here, the big one, what if we did our fractions like this, with proportion? 10 over 28, or even 28 over 10. 5 over 14. Notice how we put the fraction bar between the angle. Everybody see where we put the fraction bar between the congruent angle? If we did that, would that work as well? Yeah, that's going to work too. Because in the end, you do your diagonals, boom, 140, boom, 140. Here's your two sides, and then the angle, since the angle is congruent, bang, that's another way to get that side angle side deal. Because you see, you set up your proportion where your angle is located, that can be like your fraction bar. That's another way. I'm just trying to show as many possible options for you to show me how we get side angle side. All right, any questions on this problem? But you could, this might actually be the easiest way. If you want to prove SAS, look where your angle is congruent. But beware, you've got to make sure your sides match. Here it wasn't bad, we saw where they match. But for some of the other problems, we may not always see where those sides match. So I don't know if it's the next problem, but I think the one after, we have to figure out what. So the sides might not always match. All right, here we go. So what happened here was, here we just corresponded to sides. What we did was we corresponded with the sides. We did triangle KLM and PQR. Actually, you know what? I'll make it better. I'll make it easier. And okay. And R, P. Now, what we did was, in the past, I've always said, match them up with your sides. You put MLK over RQP. But let me, I'm going to put that up here. Oops. Now, does everybody see how we write MLK, RQP? We can write it in that order, correct? You have side, angle, side. Side, angle, side. So now, if we take MLK, boom, put it in here. MLK. That was one way I told everybody how to get your congruent statement, right? Or your similarity statement, the proportionality statement. You all remember that from a couple lessons ago? So here you do this, then you say, okay, ML, MK, KN, they're going to match with RQ, QP, PR. That's how they're gonna match. So that's where we get that first sentence here. Because in the end, in the middle, we see a 7.5. RQ is 12. So does everybody see where we're getting our similarity statement? That's the number one part. You've got to get that similarity statement. And then LK or KL, 5 over QP, which is 8. Now we need to make sure, so that's one way. You could either do the decimal value or the cross multiplying, which if you do that, you get 60. 5 times 12 is 60. Or 7.5 times 8, that's also 60. You do it like that too. Boom, I'm gonna highlight that proportion. Boom, boom, boom. And there's your numbers.
So in the south, angle C would be proportional.
Well, they be congruent. These angles are gonna be congruent.
Oh, yeah.
But these guys are gonna be proportional. So what I should have done, I would say going forward. Well, I'll just tell you, like, if you type in 7.5 over 12 and 5 over 8, you should get the same decimal value. So if you did that in both cases, what would you get? So somebody type in 7.5 divided by 12 in your calculator real quick. Tell me what you get. Yeah.
0.65.
All right. And I think you're going to get the same for,
Yeah, same thing for the.
you're going to get that for both. All right. Now, going forward, what I should have done, here's what could have made life even easier. Actually, hold on, let's see something. Okay, that you don't need to worry about. You don't have to fill in that blank. Put an X. You don't need that. But again, you kind of get that from your similarity statement because notice how L and Q match up, right? Can you see L and Q match up in the similarity statement? Does L and Q match up? It's going to be an SAS. Now, the other way we could have done it, yeah, you're going to get an SAS in the game. You get your side, angle, side. The other way you could have done it, which I think would have been easier, again, you got to make sure your sides are correspond appropriately. You could have done it this way. You could have just checked. What's 7.5 divided by 5? What would we get if we divide 7.5 by 5?
15, 1.5.
1.5. What about 12 divided by 8? What do you get if we did that?
45.
Same thing. So that's the other way. That's another. That might be a surefire way. But again, you got to make sure you know which sides are corresponding to who. Because sometimes be careful, they might flip. Because I think on our next problem, they flip. So yeah, this is also going to be an SAS. That's an SAS as well. But yeah, the other way you could do it, if you want, this might even be easier for some of you, depending on how you want to attack a problem. Bang, there you go. Get the same proportion in both cases. So you're good to go there. Because if this was a different number, then even if you did your original proportionality statement, they wouldn't work. But yeah, there is. You went back to the multiplying diagonal, that works, that can work too. So again, I'm just showing everybody multiple ways we can prove whether or not two triangles are similar. And you're going to be seeing that on your homework. Which really is only going to be 6 problems. You might not even need, it's not even going to take that long to do. Okay, questions on number 18. So again, there's more than one way you could get that answer. That's why with some of these other fraction problems, we might change it up a little. Now I think 19 is going to be a little different. And then 20. All right, here's what we're going to do. 19. Oh, this is going to be rough. All right. Let me flip this. Boom. All right. First off, let's figure out. $40 plus 66 plus something gives us 180. That's step number 1, because that's going to help us with this one right here. And then you'll figure out from there. You can tell us what we get. What's
18 plus 66 plus 74.
all right? So that's a 74. Boom. Okay. And sometimes you might have to do that. You might have to find that missing angle. They're going to give you 2. You need that third one. That's 74 degrees. All right. Don't worry about. How many boxes were on yours? Okay. This box, don't worry about it. You're not filling anything here. You got 74 degrees. Now, here's where we have to be careful. The positioning. This is what I told you all. Do be careful. Because if we look at the top triangle, some of us might say, oh, can we check what 9 over 13.5? But I think the other one, here's where you could get in trouble. I'm going to show you where. With this other triangle. Now, for the first triangle over here, we obviously see, we can put the 9 over 13.5 because there's our angle. However, for the second triangle, is where we have to be careful. We write for the second triangle, for the larger triangle, is it 21 over 14, 14 over 21, if we're going to compare these two.
14.
Yeah. I use that one. Because sometimes they're going to switch that. They're going to switch it. They're going to switch the direction. I mean, here, you could say the 14's the smaller side. So you could always put smaller side over larger side. Now, granted, if you pick larger than smaller, you flip it. So let's say if you did go, all right, let me clarify something. Let's say if you did go 21 over 14. I'm going to write this one in red. You could do 14 over 21. But if you did 21 over 14, then how must you set up the second proportion? 9 over 13 by 5 or 13.5 over 9? So let's say you did this. Then over here, you go 9 over 13.5 or 13.5 over 9 if you're going to use this method.
If we do 8.5.
So yeah, we had to flip it. So yeah, in this case, if we did this, then you have to do this.
Yeah.
So that's the concern. So that's why here, I know some of us, we see first number on top, we think, okay, now how do we set it up?
Even if it was still the same, it'd still get the same answer for both.
You should get the same answer for both. Very good. You are 100% right. I think in the end, when we, because I know in this blank, they did the original. They used the 14 over 21. And the 9 over 13.5. I think that's what we did in the original. You would have gotten, I think it's,
6 repeating.
yeah, that's that 0.6 repeat or 2/3. However, if you did 21 over 14 and 13.5 over 9, I'm not going to say that's incorrect because technically that's the same. 21 over 14, 13.5 over 9, and I think somebody said it, 1.5? Yeah. That's okay too. But again, this problem was more just make sure you know who you're matching. You get the first fraction, you go 21 over 14, you need that 13.5 over 9. If you do your diagonals, that's what you should get. You should get 189. Regardless, 189. You should get that. That is correct. You should get that then. And that'll be the same over here. So even if you did 14 times 13.5, 9 times 21, you should get 189 both ways. So, well done. Yep. And we're going to have another side angle side deal. Because there's your angle. Two sides, they're going to be similar. They're proportional. Boom. You're going to have another side angle side deal. Again, this one, you have to be careful. Which sides you match. And then, of course, you could also know right away, if you put the larger side over the smaller, you have to do the same thing here, or vice versa, smaller over larger. All right, questions before we continue? All right. Okay, here's where this one's going to be a little tricky. Here's how we're going to do this problem. All right, I'm going to write it up this way. So it might be easier for us to fill in the boxes. So what they're going to do, because here, they're going to compare the smaller triangle S, P, Q. They're going to compare this smaller triangle right here to this overall bigger triangle. That's what's happening here, ladies and gentlemen. That's what we have going on here. Now, what can we say about the tippy top of this end of both the big triangle, SRT, and a small triangle, SPQ. What can we say about the tip to top of this triangle, or this angle here? They're going to be congruent because you got the same angle. So automatically you got your angle here. So there's your angle. Boom. Now, here's where we have to be careful. To get these sides of the overall big triangle, we need to do the following. From S all the way to R. You start from S, you go all the way to R. How long is that length? From S all the way to R. Yeah. So we're going to write a different one. So we're going to have SP over SR. We're going to write it, right side up. SQ, ST. Say it again. It's going to be 16. You're right. You're right, because 4 plus 12 is 16. SR is going to be 16. So you're going to have 4 over 16. It's going to be 20. Very good. S to T is 20. Because you have 5 plus 15. 20 it is. So in both cases, 4 over 16, 5 over 20. What would be the decimal equivalent? So if we typed in 4 over 16, 5 over 20, would we get 0.25? Check it out. Use those calculators. We get 0.25 in both cases? All right. So sometimes when you're going to compare the small triangle with the biggest triangle, you have to add up the two sides. That's where we're getting the 16 and the 20. So SR is 4 plus 12. ST, 5 plus 15. That's where we're getting these two numbers. That's the most important part of the problem. Now, this second part, don't worry about this box. Well, you could say that it's a shared angle. If you want to write shared angle, you can. Or shared vertex. Because remember, RST, PSQ, they're going to share that vertex. The letter S. Notice how the S is in the middle? Remember, the middle letters are turning point. Do we agree to that? Remember that from back in the day, ladies and gentlemen? Middle letter, if you have a three-letter angle, middle letters are turning point. That's our shared vertex. Okay, I'm going to make that a little neater. Now, again, what can we say? Which theorem? What do we have here? That's the side angle side. You have two sides, angle in the middle. There you go. Questions? And then we're going to talk about the last type as well. And the last type we've kind of seen already. With the side, side, side. You've seen it already. Because that's what we were doing way before today. It was the side, side, side. Basically, match your sides. Use that proportionality statement. That's going to help you with these last four. All right, any questions before we go? Talk about the side, side, side business. Okay, are we good up to this slide? Did everybody get that information up to that slide? You better fill out that pass, and then whatever you miss, you better get back. You better get from a neighbor. These are going to be graded notes. All right, this last one. Basically, you're just going to pair your sides. And again, you get this from the proportionality statement. And we kind of already did this. Because if you have ABC, triangle ABC congruent to triangle DEF. Remember, put your ABCs, boom. Put them right above or right below. And then that's how you're going to pair them off right here. 1 second. So we kind of seen this already. We've seen this already. Yep. So you get the similarity statement, helps you get the proportionality statement. Once you get that, then we're back to where we were before. I think, yeah, one of these. No, two of them are going to be of this type. 2 homework problems. Okay. Are we ready, ladies and gentlemen? Ready? Christian? Alex, everybody, Andy, Catherine, Jason? Okay. Here we go. Now, what we did LMN. We just went ABC order. And same thing. No, I didn't go ABC order. Okay, here, I better be careful. Because, I apologize, I did not go ABC order here. Not for the second try. However, this one's not bad because you already know who's going to match with who. Because you know these two sides are going to match up with those two sides. And then this bottom side has to match with that bottom side. So you know right away who's going to match with who. It's going to be 2, yeah. Because basically, you multiply by 2 to go from the smaller to the larger triangle. That's times 2. Times 2. And then for that last one, times 2. Now, similarly, you can divide by 2 to go from the bigger to the smaller. So we kind of seen this already. This first one, we definitely have. They're gonna be similar. Because once you match your first with the second, you simplify in all three cases, you're gonna get the same value. So right away, since all three proportions give you the same result, or all three ratios give you the same result, can we say these two triangles are similar? Can. All three cases, it's going to work. That's the side deal. Because this side is proportional to that one. Same thing, same thing. Because we went from smaller to bigger, multiply them all by 2. Bigger to smaller, we all divide it by 2. Bang, you get the same one. So we have kind of seen side before. We've seen it before. But again, the key is you've got to get that order. You've got to get that order correct on the homework. All right, so far questions on this first problem. All right, second problem. Again, we need to figure, this one's not bad. You know why? You know who's going to match with who. Because right away, if you take your first one, AB, you can say AB is the longest side out of the 3, right? You can write longest over, what's the longest side in the other triangle? PO. So there you go, you got the longest, so it's 36 over 24. Now what about medium, or the middle? Which one's like the middle, or the second longest, or the AC and O. AC 30 and O 20. And then of course BC and NP have to match up. They're the shortest. Up. Boom. Even though this is different, like how we see it here, how I wrote it there, it's still going to be the same. Because in the end, when you simplify all three of those ratios, what should we get? What's that? Close. 1.5. You get 1.5 or 3 over 2. You flip them, that's good too. So therefore, can we say just like before? Boom. They're all equal. Then just like before, we have what type of similarity theorem? That's all three sides. Since the three sides are going to match, boom, there you go. Questions? So I want to make sure everybody. So again, there's more than one way we can match our sides. And the nice thing about the triangle, usually you can go smallest, medium, largest, or largest, medium, smallest. Now with isosceles, it might be the same. You might have two that are the same. That's okay. All right. Questions before I go to the next slide? All right. Next one is very similar to this one. Basically, we did the same thing. We matched the two largest sides. (21, 42). So 21 over 42, 1/2. And the medium, 20, 40. That's also 1/2. And then 11, 22. Boom. Okay. We have what do we have here, ladies and gentlemen? Side. So yeah, pair, put them in order. If you put them in order, that's gonna help too. You put your three sides, smallest to largest, or largest to smallest, that's fine. Once you know who you're pairing, you have to figure out who you pair with. But if you get that, bang, you got a mate. So yeah, again, pair them up. But make sure, like here, we put the smaller triangle value over the larger triangle. But again, we want biggest side, medium side, smaller side. And then sometimes what might help might be a table. I'll show you. Small triangle, large triangle. And then here's what you do. Small side or larger side. You know what, we can do that. So the side did larger side. Oh, come on. Oh, come on. So you can put largest, medium, shortest side. So then you figure out, that might help you when you set up your proportions. Label your rows, label your columns. And then you know exactly what numbers are going to go where. So that might be, so medium side, smaller side, largest side. So that might help too. So I'm just showing everybody ideas. Another idea when you set up your proportion. Questions on this problem? Then the last one, here's what happened with the last one. You may not see this so much on your homework, but if you look at the smaller triangle, they're all fours. So for the smaller triangle, they're all fours. Now for the larger triangle, all 6. The bottom one is obviously 6, but then the other two have to also be, well, what's 4 plus 2? 4 plus 2. Boom. That's just another side situation. Very good. Okay, questions? So what I want to do, 2 things before we go. Thing number 1, I'll make sure we do our notes. Because thing number 2, notes. All right. Give me what I see. You. Notes. Just make sure we did them all. Did we get all our notes? Catherine, got them? Got it. If you want to see a couple pages, please. Christian, tell me your notes real quick, please. Everyone, notes. Annalie, you're good. Great, notes, can I just see you make sure we copy everything? Couple books back, you okay, yep, good. Sure. All right. Just ask schools and neighbors about, because I'm going to talk about the homework real quick. Ask them what I told. All right, good. Got him. All right, Jeff. Good. Okay, so everybody get the home. Everybody's gonna get a grade for class notes. All right, real quick. Okay, hang tight before we run. Okay. On the homework, couple things I want you to do. Okay, don't put your homework away yet. You keep it. I can put it in the book. All right, time out. Okay, we're not done yet. You want to listen to what I'm going to tell you on how to make your life very easy with your homework. You might want to listen up. Okay, here we go. The similarity criterion. You put one of the following. It would either be like the SSS, SAS, or AA. That's what you're going to put for the similarity criterion. So that's what you do for all 6 of them. It's going to be one of these, but you're going to tell right away which one it is. Because it's either going to be, if it's all 3 sides, then it has to be SSS. If it's 2 sides and an angle, then it has to be SAS. And then for number 4, it has to be AA. Now, real quick for your triangle, make sure you get your similarity statement right. That's when you have to pair up. So you went from A, B, C, R, P, Q. She went medium, largest, smallest. That's what I'm worried about the most. Similarly over here, we went from R, S to T. So for this other one, we need, where should we start? Be careful. We start at K. Oh, go ahead, I'm sorry. You have to go from L and K. You went shorter, angle, larger side. So yeah, L and K. And then this one, we went from S, T, U, Y, W, X, V. Yup. No arcs, 1 arc, 2 arc. And that's the other way you can label it. 0, 1, 2. You gotta go 0, 1, 2. 0, 1, 2. Triangle. W, X, V. Congratulations, you already done half your homework. Zoe, Valerie, did we already get half our homework done? No.